Well, the space object 3I Atlas just whipped past the Sun, and instead of clearing things up, the new images made everything even stranger. Because if this thing really is a comet, then it's the strangest comet ever recorded. And if it's not a comet, then we're watching something completely new invade our solar system. So, should we be worried? This all started back in July 2025. Astronomers using the Atlas Survey Telescope in Chile spotted a faint, super fast-moving object, something unlike anything they'd seen before. That was our first look at 3I Atlas, and right away, scientists had a lot of questions. Where did it come from? What's it made of? But more importantly, what is this thing? At first glance, it almost looks like a tiny cell, right? Like something you'd see under a microscope, with a bright center like a nucleus, and this fuzzy outer layer. But when we look at it from a different angle, the mystery clears up. That glow is actually a comet tail. It's precisely because it looks like and behaves like a comet that NASA finally confirmed it. Yup, 3I Atlas really is a comet. The big giveaway is that it has an icy nucleus and a coma, which is that glowing cloud of gas and dust surrounding it. But this comet is a very special one because it didn't come from our own solar system. It came from somewhere else in the Milky Way, and that's ridiculously rare. To give you an idea, we've only ever seen 3 objects like this, period. The first 2 interstellar visits were the famous Oumuamua and the comet Borisov. And now, 3I Atlas. Cool. But you might be asking, how do we know it actually came from outside our solar system? You see, normal comets are bound to the Sun. They swing around it in these big, looping orbits. But 3I Atlas isn't doing that. Its crazy speed and path show it's not on a closed orbit around the Sun. And the only logical explanation is that it came from another star system and, just wandered into ours by chance. In other words, this is just a visitor passing through our solar system, and is doing it at a ridiculous speed. When we first spotted it, it was going around 137,000 miles per hour. So this object probably spent millions of years cruising through deep space just to hang around our solar system for a few months. And after this quick visit, it'll vanish into interstellar space, and we'll never see it again. Recently, 2 European Space Agency satellites, along with several NASA spacecraft near Mars, captured new images of 3I Atlas zooming in as it passed the red planet. And one of those images is pretty incredible, showing a cloud of hydrogen atoms around the comet. Scientists were pretty excited about that, as every bit of information we get from this visitor matters. Because the reality is, there are still a lot of unanswered questions about this object, starting with its size. We can't pin it down exactly yet, but NASA says it could be anywhere from about 1,400 feet to around 3.5 miles in diameter. Its exact shape is another mystery, because our telescopes can't really get a clear look at it. The nucleus is buried inside this bright coma of gas and dust, and the sunlight reflecting off all that dust basically blinds us. So for now, we're trying to see it through a bright, dusty fog. If you put all the pieces together, its behavior, its chemistry, and the images we've gotten so far, everything points to 3I Atlas being a comet. But even with all that, there are still some pretty controversial ideas floating around about what it might be. Not long after it was discovered, Harvard astrophysicist Avi Loeb said there's maybe a 30 to 40% chance this object isn't something naturally formed. That comment kicked off a wave of online buzz, with people jumping to wild possibilities. Like maybe it's some kind of extraterrestrial tech, or worse, a threat to Earth. Ooh. According to this theory, 3I Atlas might be a massive extraterrestrial mothership. Its odd trajectory could mean it's sending out little satellites toward Jupiter to collect intel for some extraterrestrial civilization. So, in that version of the story, this isn't just a comet. It's basically advanced space spy tech. But then the obvious question is, why spy on Jupiter, right? I mean, wouldn't Earth be way more interesting to an interstellar civilization? Well, in this theory, Jupiter is the target because it's so much bigger than Earth and the other neighboring planets. The idea that a planet that massive could act kind of as an interstellar beacon, something that stands out from far away. The region near Jupiter is another big reason. It's almost like it's an ideal parking spot, where space technology could basically hang out without using much fuel at all. In other words, if you were going to place advanced satellites somewhere to watch a planet, well, that's prime real estate. Pretty cool, huh? But as fun as that theory is, we gotta come back down to Earth for a second. According to the major space agencies, this thing is a comet, case closed. But that label doesn't make it any less special. 3I Atlas is still a total weirdo in the best way, and it stands out for a bunch of reasons. Let's look at 3 of the most important ones. First, this object is old, like really old. Older than me. Scientists think it's been traveling through space for at least 7 billion years. That's so far back in time that it was formed before our Sun and Earth even existed. So yeah, it's probably the most ancient thing we've ever seen in our cosmic neighborhood. Second, its glow. Comets can sometimes look kinda green, and here's why. When a comet gets closer to the Sun, the ice inside it heats up and starts releasing gas. I know the feeling. Some of that gas is made of carbon-based molecules, especially one called diatomic carbon, or C2. When sunlight hits those molecules, they light up, and to us, that glow shows up as green. But with 3I Atlas, that green color is, well, confusing. The data suggests that this comet is actually low on those carbon chain molecules. So, the big mystery is, if it doesn't have much C2, how is it glowing green at all? Well, nobody knows. And now, the third thing that makes this comet stand out. It seems to be giving off a metal alloy we've basically never seen in nature. So this comet is releasing a plume that contains nickel. That's normal. What's strange is what's missing: iron. In comets, nickel and iron usually show up in pretty similar amounts. Here, we're seeing nickel, but no clear sign of iron. And that's almost unheard of. If the data holds up, it points to an alloy called nickel tetracarbonyl, something we've only ever seen before in human-made industrial processes, not out in space. No other known object has shown this kind of signature. Well, now that you're familiar with 3I Atlas, we gotta answer the biggest question of all. Is it a threat to us? Good news! No, the comet isn't dangerous, and it's going to stay really far from Earth. So we can all take a deep breath. Well, I feel better. Although it's harmless, tracking it has been super valuable for planetary defense. You see, space agencies are always watching asteroids and comets, running the numbers on their orbits, and making sure we'd get a warning if something ever did head our way. But 3I Atlas gave them something new to practice with. This is the first time tracking data from spacecraft orbiting another planet were officially submitted to and accepted by the Minor Planet Center. That's the big global database where asteroid and comet observations get collected and checked, so scientists everywhere can stay on the same page. So, in a way, 3I Atlas was like a rehearsal. Gathering data like this from a totally new setup helps researchers sharpen their methods and improve how we spot future space objects. And that means better detection, faster tracking, and more readiness, just in case the next visitor isn't quite so friendly. Uh-oh. A large space probe is nearing the Sun. The terrifying heat of the star begins to melt the shell of the spacecraft. Another moment, and the probe bursts into flames. In no time, it disintegrates in a powerful explosion. Ah, what a sad ending. If it were true, it was not a probe. It was a comet known as 3I Atlas. And despite everything people say, it's still intact and thriving. The thing is, there is a rumor online saying that comet 3I Atlas exploded when it got closest to the Sun. But astronomers say this is not true. There was no explosion, and the comet's nucleus still looks whole and undamaged, which is kinda surprising, since comets that pass very close to the Sun usually go through some serious changes. You see, comets are made of a mix of ice, dust, and rocky material, which is why they're often called dirty snowballs. So, when they come close to the Sun, the intense heat from our star makes their ice turn into gas. This new gas can burst out in huge jets, form a cloud around the comet called a coma, and/or be pushed away into a long tail. Sunlight makes all of these parts shine more brightly, and even people with small or simple telescopes can study the comet if the viewing conditions are good. But aside from being a breathtaking view, such a close approach can break off pieces of a comet or even tear its whole nucleus apart. Now, it's true that some comets survive this process, but many, especially small ones, or comets entering the inner solar system for the first time, break into pieces or disappear completely. Well, 3I Atlas acted differently. So there. It reached its closest point to the Sun on October 29, 2025. This point is called the perihelion. At that moment, the comet was about 130 million miles from the Sun. That's about 1.5 times the distance between the Sun and our planet. The comet was also on the opposite side of the Sun from Earth, so the star was blocking it from our view and we couldn't see the comet. Anyway, even though 3I Atlas could hypothetically break apart or release lots of fragments, it didn't. The nucleus stayed intact, and this made the comet's behavior even more unusual and interesting to scientists. They looked closely at the new photos and said everything looked normal. Now, interestingly, the day before, some people thought the comet had broken into pieces after it came out from behind the far side of the Sun. This idea became popular after a blog post said the comet had lost a lot of mass. So, to make this claim, the blog used photos taken on November 9th by 2 small telescopes in Spain. The pictures show jets of gas coming out of the comet. The scientists used this to estimate how much material was coming off the comet, claiming that it should have broken into at least 16 pieces. However, many scientists have questioned this statement. Most researchers say there's no proof that the comet exploded. One scientist who studies the comet says that all the images he had seen showed a completely normal, healthy comet. There's no sign that the main body of the comet has broken apart. Still, now that the comet is coming back into view, astronomers are watching it very carefully. They want to learn more about the comet's materials and structure. Right now, if you look at it from Earth, the comet seems to be slowly moving higher in the eastern sky. If the weather is good, people in many parts of the northern hemisphere can see it with a small telescope, like this one with a 6-inch lens. And many do pay attention to the comet. Since it was discovered in July, it has become the center of many curious ideas. Some people are sure that the comet, which comes from outside our solar system and might be more than 7 billion years old, could be a probe sent by a different civilization. Now, most astronomers strongly disagree, of course. They believe the comet is completely natural and comes from another star system somewhere in the Milky Way. And this is actually exciting. Comet 3I Atlas is only the 3rd interstellar comet ever seen, and it is the largest one of its kind. Before, it was Comet 2I Borisov that passed through in 2019, and Oumuamua, a weird elongated object that appeared in 2017. But 3I Atlas, with its up to 3.5-mile nucleus, dwarfs Oumuamua, which was just a 1/4 mile long, and Borisov, which is about 3/10 of a mile across. Plus, 3I Atlas may be the oldest comet humans have ever observed. Oumuamua is much younger, around 1 billion years old. It came from the galaxy's thin disk, where new stars are still being born. It was the first known object from another star system to pass through our solar system, basically our first interstellar guest. It was super stretched out, about 10 times longer than it was wide, unlike anything else we've spotted in space. As for 2I Borisov, it sits in between, at roughly 1.7 billion years old. It also came from the thin disk. It was the first confirmed comet to come from another star system, and it gave scientists a super rare peek at what materials beyond our solar system were made of. Unlike the first interstellar visitor, Oumuamua, which looked more like an asteroid, Borisov behaved like a classic comet. It had a bright coma, a temporary fuzzy atmosphere of gas and dust forming around the comet's nucleus as it approaches the Sun. Plus, it also had a long tail of dust and gas. Now, 2I Borisov is speeding away from the Sun and will never return. But it allowed scientists to take a glimpse into the chemistry and history of distant worlds. Now, let's get back to Comet 3I Atlas. It will pass closest to Earth on December 19th. Until then, scientists will make many more observations. People will also make many new claims about the comet, that's for sure. But it's best to be cautious and not believe everything immediately. By the way, even though you can't see this famous comet with your own eyes or with a regular telescope, hey, that's good news. A powerful telescope in Italy is streaming it live for free. Whoa! So anyone can actually watch this mysterious object as it passes by. Scientists think this comet weighs about 33 billion tons. That's a big number. How about we make a few comparisons? The Eiffel Tower weighs around 10,000 tons. So, 33 billion tons is the same as 3.3 million Eiffel Towers. And if you decide to compare the space visitor to buildings, well, 33 billion tons is about the same as the weight of several huge city areas made entirely of steel and concrete. Now, 3I Atlas was first noticed in July by NASA's Asteroid Terrestrial Impact Last Alert System, which, if you're paying attention, is where they got the nickname Atlas. Shortly after, NASA confirmed that the object wasn't from our solar system at all. Now, besides being huge, 3I Atlas is unusual in several other ways. As it moves through the solar system, it's releasing massive amounts of carbon dioxide and dust. So this suggests that 3I Atlas is 3 to 5 orders of magnitude, which means 1,000 to 100,000 times more massive than the two other known interstellar visitors. Such an enormous difference is a real scientific mystery. It's also traveling incredibly fast, about 150,000 miles per hour, which is almost 200 times the speed of sound. Hey, that will get you a speeding ticket. And unlike objects in our solar system, which follow curved paths because of gravity, 3I Atlas is moving on a nearly straight line. That alone makes it stand out. Now that the comet has moved past the Sun, telescopes on Earth can see it again. Comet 3I Atlas is important to us because it's only the third interstellar visitor we've ever seen, and it may be the biggest and oldest one yet. And it didn't break apart near the Sun like some other comets. By studying it, scientists can learn what materials exist in other star systems and better understand how comets, and even planets, form in our galaxy. A mysterious space visitor has recently passed its closest approach to Earth, flying by at a distance of 64 million miles. It might be something totally natural and born on the outskirts of the solar system, or some unknown civilization could be examining us from above right at this moment. This new object looks a lot like another strange wanderer called 3I Atlas, and you'll understand why we say strange pretty soon. So, could both of them come from the same place outside our solar system? What we do know is that this new object is relatively close to us, in space terms of course, and scientists are now studying it closely. They first spotted it inside our solar system, and people are paying attention because it showed up not long after 3I Atlas passed near our Sun. On November 2, 2025, astronomer Gennady Borisov, the same person who discovered interstellar comet 2I Borisov in 2019, found this new object. It's now got its official name and is listed in NASA's and the Minor Planet Center's databases. C-2025V1 has some unusual features. Its orbit is tilted 113 degrees, which means it's moving almost up and over the regular path that planets take. Even more bizarre, its orbital plane is almost at a right angle to the path of 3I Atlas. Plus, it doesn't have a clear comet tail, which is odd. Right now, its orbit has an eccentricity of 1.0095. And let me break it down in human language. If that number was well above 1, it would mean the object definitely came from outside the solar system. But because it's only just a bit above 1, the most likely explanation is that C 2025 V1 came from the Oort cloud. That's a giant faraway shell of icy objects that surrounds the solar system. Now scientists check this by basically rewinding the object's path, sending it all the way back to about 1000 AU. That's 1,000 times farther than the Earth is from the Sun. At that huge distance, the planets can't mess with its motion anymore. When they redo the orbit from that point, its eccentricity, the number that tells you if it's from outside the solar system, usually drops below 1, which means it's still part of our solar system. But at the same time, even a tiny push from Jupiter while passing by could make even a normal Oort cloud comet look like it has an eccentricity slightly above 1. And on top of that, small blasts of gas coming off the comet's surface can also change the numbers a little. So, to put it simply, it probably isn't interstellar. It just looks that way because of small pushes and gas bursts. C 2025 V1 is still exciting, even if it comes from the Oort cloud, because studying it gives us a chance to analyze the material from that distant region and learn how our solar system formed and evolved. Now let's get back to the mystery of 3I Atlas. Before anything else, let's explain what 3I Atlas actually is. It's most likely a comet, basically a huge, dirty snowball flying through space. You can't see it with your own eyes or with a regular telescope. But there's good news. A powerful telescope in Italy is streaming it live for free. So anyone can actually watch this mysterious object as it passes by. Scientists think this comet weighs about 33 billion tons. That number is hard to imagine, so here are a few comparisons. The Eiffel Tower weighs around 10,000 tons. So 33 billion tons is the same as a whopping 3.3 million Eiffel Towers. And if you decide to compare the space visitor to buildings, 33 billion tons is about the same as the weight of several huge city areas made entirely of steel and concrete. But even all that size isn't the wildest part. Some experts think this object might be a piece of unknown technology from outside our galaxy. And they're not saying this just for fun. There are real reasons behind the theory. 3I Atlas was first noticed in July by NASA's Asteroid Terrestrial Impact Last Alert System, or ATLAS. Shortly after, NASA confirmed that the object wasn't from our solar system at all. It's an interstellar object, only the third ever discovered. The first one was Oumuamua in 2017, which looked long and flat and didn't behave like a normal rock. The second was Comet BI Borisov in 2019. Now we have 3I Atlas, and it is enormous compared with the other two. Its nucleus is up to 3.5 miles wide, while Oumuamua was only about a quarter mile long, and Borisov was around a half mile across. Besides being huge, 3I Atlas is unusual in several other ways. As it moves through the solar system, it's releasing massive amounts of carbon dioxide and gas. This suggests that 3I Atlas is 3 to 5 orders of magnitude, which means 1,000 to 100,000 times more massive than the other two known interstellar visitors. Such an enormous difference is a real scientific mystery. It's also traveling incredibly fast, about 150,000 miles per hour, which is almost 200 times the speed of sound. And unlike objects in our solar system, which followed curved paths because of gravity, 3I Atlas is moving on a nearly straight line. That alone makes it stand out. These odd behaviors have led some researchers to consider a pretty unexpected idea. 3I Atlas might be a probe sent by another civilization, possibly to study Earth. According to this theory, the object could be a sign of some kind of intelligence from beyond our solar system. Why do they think this? Well, because the object's movement doesn't match what you'd expect from something controlled only by gravity. It also passes close to Venus, Mars, and Jupiter, and these are the planets that might be especially interesting for an outside civilization to observe. Another very unusual feature of 3I Atlas's path is that its orbit is tilted only a little compared to the plane of the solar system, about 5 degrees, and it moves in the opposite direction to most planets. This feature might allow the object, or its creators, to take extremely precise measurements of planets, things like their orbits and sizes, to plan a perfect flight route through the solar system. And if 3I Atlas suddenly changes direction at some point, that could mean it's using a built-in engine instead of simply drifting through space. Now, new photos have also shown that 3I Atlas has at least 7 jets blasting material into space, some shooting in totally opposite directions. Now, if this thing is just a normal comet, it would have had to lose a huge amount of its original mass when it passed near the Sun, way more than just 10 to 20%. Only some of that material would actually push the object in one direction, so the total amount blown off would need to be massive. If that's what happened, then there should be now a giant cloud of gas and dust around 3I Atlas. And if that cloud exists, it'll be pretty easy to figure out what the comet is made of. The James Webb Space Telescope will check this when 3I Atlas gets closest to Earth on December 19, 2025. But if 3I Atlas is not a normal comet and is actually some kind of technology, it wouldn't need to lose that much material. Engines built by an advanced civilization could give it a boost while using way less gas because they shoot it out way faster. Faster exhaust gives more push with less fuel, so a technological object wouldn't need to blast away big chunks of itself the way a natural comet would. So, to sum it up, there's still a big mystery around 3I Atlas. Could it really be a technological mothership that released small probes into the inner solar system? But C-2025 V1 doesn't fit that idea, unless one of the objects used some kind of engine. The closest their orbits ever come is about 46 million miles, and the two objects themselves were never closer to each other than about 140 million miles. The tiny non-gravitational push detected in 3I Atlas is nowhere near strong enough to close this gap. So, C-2025 V1 is almost certainly not one of the mini probes people imagine 3I Atlas might have released.
Comet 3I Atlas crashes into Earth, and a wave of widespread destruction starts shaking our planet. Ginormous tsunamis are swallowing coastlines, devastating earthquakes are cracking the ground. Hot debris is igniting massive firestorms. Thick clouds of dust are blocking the sun. Now, that's what could happen if 3I Atlas, a massive comet traveling through the solar system, collided with our planet. But can this disaster actually occur? When will 3I Atlas be the closest to Earth? Let's figure this out. First of all, this comet turned out to be way larger than we previously thought. Its weight is likely a whopping 33 billion tons. Let's throw in a few comparisons to put it into perspective. The Eiffel Tower weighs about 10,000 tons. So, 33 billion tons is roughly the weight of 3.3 million Eiffel Towers. Impressive! Next, all the cars on Earth, and we're talking about 1.5 billion vehicles, each weighing about 1.5 tons, weigh approximately 2.25 billion tons. This means that the comet's mass is 15 times greater than the combined weight of literally all the cars on the planet. And finally, compared to buildings on Earth, 33 billion tons is equal to several large metropolitan areas made entirely of steel and concrete. But the whole idea of how big this comet is fades in comparison with an even crazier fact about it. It could be unknown technology from a different galaxy, and some experts are somewhat sure about that. But why? 3I Atlas was first spotted in July by NASA's Asteroid Terrestrial Impact Last Alert System. A bit later, the U.S. Space Agency confirmed that the object was an interstellar object, only the third we have found so far. Before, it was Comet 2I Borisov that passed through in 2019, and Oumuamua, a weird elongated object that appeared in 2017. But the newest comet, with its up to 3.5-mile nucleus, dwarfs Oumuamua, which is just a quarter-mile long, and Borisov, which is about 0.6 miles across. By the way, some believe that the comet could be even bigger, up to almost 7 miles, but scientists haven't found any proof of that yet. Besides its size, 3I Atlas is different in other ways too, which makes some scientists question its origins. The object is shedding huge amounts of carbon dioxide and dust while zooming towards the sun. It's most likely the proof that 3I Atlas is more massive than the other two interstellar objects by 3 to 5 orders of magnitude, which is basically a serious anomaly. The comet is also traveling toward the sun incredibly fast. We're talking about around 130,000 miles per hour, which is almost 170 times the speed of sound. Another weird thing is that this interstellar object is following a straight trajectory, unlike anything else in the solar system. Most space bodies move along curved orbits due to the force of gravity. That made some researchers believe that 3I Atlas might be a probe sent by another civilization to explore Earth, possibly with not-so-friendly intentions. Their theory is that the object could be a technological artifact, a sign of cosmic intelligence. You see, the comet moves in a pretty weird way that doesn't totally line up with just gravity. Its trajectory also takes it close to Venus, Mars, and Jupiter. And researchers think that these planets might be especially interesting for another civilization to pass by. Another bizarre fact, the space traveler also spins backward compared to most stuff in our solar system. This might be necessary to make it easier for 3I Atlas to get near Earth without much resistance. Some scientists think the comet's odd spin and flight path could help whoever or whatever made it take super precise measurements of the planets, things like their orbits and sizes, to plan a perfect route through the solar system. If 3I Atlas suddenly changes direction in a big way, that might mean it's using some kind of built-in engine instead of just drifting through space. There's also another theory that suggests it could be a piece of unknown tech that's still active. There's no need to worry though, at least at the moment. The comet isn't coming anywhere near us. NASA says it'll stay around 150 million miles from Earth when heading toward the sun. So the question is, where do such space visitors come from? Astronomers have found that the 3 interstellar objects we discovered came from totally different parts of the galaxy. And each of them has its own age and background. 3I Atlas turned out to be the oldest, about 4.6 billion years old, and it came from the Milky Way's thick disk. That's a region filled with older stars that have fewer heavy elements. 1I Oumuamua is much younger, around 1 billion years old. It came from the galaxy's thin disk, where new stars are still being born. Oumuamua, Hawaiian for a messenger from afar arriving first, was the first known object from another star system to pass through our solar system. Basically, the first interstellar guest. It was super stretched out, about 10 times longer than it was wide, unlike anything else we've spotted in space. It also sped up in a way that couldn't be explained by gravity alone. Changes in brightness showed it was tumbling end over end instead of spinning smoothly. At first, scientists were confused because the space body didn't have a tail or cloud of gas like a normal comet, even though it was accelerating. That led to a lot of debate about what it was made of and where it came from. Just like with 3I Atlas, some people wondered if it could be technology created by a space civilization. But most scientists now think Oumuamua was a totally natural object, just a really weird one. The best guess is that it was a comet releasing invisible hydrogen gas, which caused it to speed up slightly. Sadly, by the time astronomers found it, it was already heading out of the solar system, so there wasn't much time to study it. As for 2I Borisov, it sits in between at roughly 1.7 billion years old. It also came from the thin disk. It was the first confirmed comet to come from another star system, and it gave scientists a super rare peek at what materials beyond our solar system were made of. The comet was discovered in 2019 by Gennady Borisov, an amateur astronomer who actually built his own telescope to search for faint space objects. Unlike the first interstellar visitor, Oumuamua, which looked more like an asteroid, Borisov behaved like a classic comet. It had a bright coma. That's a temporary fuzzy atmosphere of gas and dust forming around the comet's nucleus as it approaches the Sun. Plus, it boasted a long tail of dust and gas. Studying 2I Borisov helped researchers learn more about how other planetary systems form. Observations showed that its dust grains were compact and that the amount of gases like carbon dioxide changed a lot as it approached the Sun. It could mean that the comet formed under very different conditions than anything else in our solar system. Now, 2I Borisov is speeding away from the Sun and will never return. But it allowed scientists to take a unique glimpse into the chemistry and history of distant worlds. Interestingly, the differences between these three space objects suggest that interstellar visitors have been getting kicked out of planetary systems all across the galaxy for billions of years, so it's not something new. To figure out if 3I Atlas might be some kind of probe from another planet, scientists are checking for any signs of technology, like strange radio signals, electric activity, and weird movement patterns. If the comet suddenly changes course or drops smaller objects nearby, it might be our cue. But even though 3I Atlas is moving in a pretty wild and energetic way, it's most likely just a natural interstellar object passing through. Researchers say they'll need a lot more proof before anyone can seriously say the space wanderer was sent by someone from another planet. What do you think about this newly discovered space traveler? Share your opinion in the comments.
Kaboom! One huge asteroid could be enough to wipe out all dinosaurs that ever roamed the Earth, leaving behind nothing but a huge crater. Yeah, we're in the Yucatan Peninsula, Mexico, and underneath there's Chicxulub, a massive crater. Now, if there's this immense hole, there must be a meteor too, right? Well, weirdly, no one has ever seen the actual remnants of the space rock itself. It's a bit weird, especially considering how important it is. After all, many think the same meteor that created the crater is the one that wiped out dinosaurs. Now, it might have vaporized on impact, creating a massive explosion. Most of the meteor could have turned into gas or tiny fragments scattered across the atmosphere. Or it might still be here, on Earth, just hiding. And scientists have finally discovered where to look for it. But it's not easy to reach. Around 66 million years ago, a giant asteroid went down and marked the end of the Cretaceous period. It slammed into what's now called Mexico, just north of Central America. The explosion from the impact triggered a global heat wave, which was followed by years of winter. It threw Earth into total chaos. The consequences of this catastrophe led to the extinction of more than 60% of life on Earth, including all the non-avian dinosaurs like T-Rex and Triceratops. It also took down flying reptiles, pterosaurs, and sea creatures like mosasaurs. Long story short, it was the end of the dinosaurs era. But don't be too sad about it, because it paved the way for the rise of mammals and you and me. Anyway, scientists have recently figured out where the infamous asteroid came from and where it ended up. The thing wasn't just wandering around Earth's neighborhood. This massive rock might have formed beyond Jupiter and headed straight for our planet. But we'll talk about that a bit later. First, let's look more closely at the collision that created the Chicxulub crater. When the asteroid slammed into Earth, Rocks from deep within the planet's crust were thrown up to 15.5 miles into the sky. It also created mountains taller than the Himalayas around the crater's edge. The asteroid itself, called the Chicxulub impactor, was about 6 to 9 miles in diameter. It hit Earth at a speed of around 12 miles per second, coming in at a 60-degree angle. I know we're not in a geometry class, but the angle is important here, since it was exactly right to send the maximum amount of vaporized rock into the atmosphere. As a result, massive plumes of sulfur gases and fine dust shot up, blocking out the sun and causing what's known as an impact winter, which lasted about 15 years. At the time, dinosaurs reigned on Earth. They'd been around for nearly 200 million years before the catastrophe led to their disappearance. The meteor theory seems all plausible, and all the facts add up, but even now, not everyone agrees with that. Some believe that dinosaurs were already on the brink of extinction before the asteroid impact, and the collision might have just sped up the process. Anyway, most dinosaurs were wiped out, but if scientists are right, then those who somehow managed to survive were the ancestors of modern-day birds. So we have an idea of what might have happened, but it took years of studies. The crater was first identified by scientists working for Pemex, a Mexican oil company, in the 1970s. And sometime later, scientists finally realized the mass extinction event that ended the Cretaceous period was because of the Chicxulub. One piece of evidence that pointed to the asteroid were the local fish back then. You see, when the asteroid struck, the immense force of the impact reshaped the planet's surface. For example, it turned rocks into glass-like spherules. Now, spherules are like small spherical particles that can form from the rapid cooling of molten silica droplets. And some of these spherules ended up in the gills of fish that were wiped out by the impact. So, when during another research, scientists studied these fossils, it became obvious to them that the asteroid strike had happened during springtime in the northern hemisphere. They figured this out by studying the lines of growth in the fish's bones. Yep, those can be read just like tree rings. Of course, throughout many years, researchers continued exploring the impact site, hoping to find new data about the catastrophe. Their best bet was to turn to the chemical record left behind by the asteroid, the debris of which is hiding under all those layers of rock and sediment under the Yucatan Peninsula. So they studied the chemical signatures in rocks from the end of the Cretaceous period and found that the asteroid came from beyond Jupiter. And it wasn't just any asteroid. No, it was a carbonaceous chondrite, one of the oldest types of asteroids in the solar system. It most likely formed billions of years ago. These types of asteroids only come from the region beyond Jupiter. So the asteroid that caused the extinction event must have originated there. One of the main clues was ruthenium. It's a rare element in Earth's rocks, but much more common in asteroids. Scientists detected tiny amounts of ruthenium in the rocks, which helped them confirm that the asteroid came from outer space, not from a comet or volcanic eruptions. In 2016, scientists also published the first results from a drilling expedition into the Chicxulub crater. The team managed to drill more than 4,000 feet beneath the seafloor, getting their hands on core samples containing pieces of the original granite bedrock that was struck by the asteroid. These rocks are deeply shocked and placed out of order on top of sedimentary layers. It supports the theory that the peak ring of the Chicxulub crater formed through a dynamic collapse process. Now, about that peak ring. Scientists specifically targeted it in their exploration. The so-called ring is a circular ridge inside the crater rim. Similar peak rings can be found in the largest impact craters in our solar system, on the Moon, Mars, and Mercury. But on Earth, Chicxulub is the only well-preserved crater with a peak ring. This discovery also aligns with recent findings from NASA's lunar mission. It showed that the peak rings within the Orientale impact basin on the Moon had formed in an equivalent way to those at Chicxulub. The team is so eager to study the peak ring, because they want to test their models of crater formation. Plus, they hope to find out whether this area could have been one of the first habitats for microbial life after the asteroid impact that wiped out dinosaurs. The peak ring formed just minutes after the impact. The deep granite bedrock, initially flowing like a liquid, rebounded into a central tower as tall as 6 miles before collapsing into the ridge we see today. This was followed by a layer of breccia. That's a jumble of rocks and impact melt. And after that, ocean tsunamis brought massive amounts of sandy sediment into the crater. Another find from 2016 was a 10-foot-long core, which revealed bits of granite and minerals from hot, fluid-filled cracks. That was a sign that they had finally entered the peak ring. Geophysicists from the University of Texas explained that they had expected the peak ring to be a large hydrothermal system, and they were drilling to confirm this. The team eventually reached deeper layers, drilling down to 4,380 feet. The team was able to collect most of the core samples they hoped to get, and the samples they got were in great shape. They also gathered lots of useful data from the early Paleocene period and completed a successful scan of the drill hole. Now, scientists from around the world will need some time to fully study and understand what these findings mean. But they're sure that this mission will help answer some big questions, like what exactly happened when the asteroid hit, how it wiped out the dinosaurs, and how impacts like that affect life deep underground. While some astronomical events are pretty common, there are those which occur only once a year or once in 100 years. Let's have a look at the coolest and rarest events we might be able to see with our own eyes. The first amazing celestial event on our list is the Perseid meteor shower that will take place from the 17th of July to the 24th of August 2024. This event is going to be one of the most vibrant of the year. At its peak, between the 12th and 13th of August, you might see up to 100 meteors per hour, if you're in a dark place, that is. This meteor shower is caused by debris from the comet Swift-Tuttle. As meteors streak through Earth's atmosphere, they often leave behind long wakes of light and color. The perfect time for watching this cosmic show is right before dawn. On the 2nd of October 2024, we'll be able to watch a ring of fire solar eclipse. Its scientific name is an annular eclipse, and it occurs when the moon is slightly farther away from our planet. In this case, when the disks of the moon and the sun align, the moon's shadow doesn't completely block the sun's light. As a result, you can see a ring of sunlight around the moon. This time, the ring of fire will be visible in southern Chile and southern Argentina, so book your flights early. Another cool event that will occur this October is the Draconid meteor shower. During this event, meteors are more likely to fly in the evening hours than in the early morning. This is usually a slow shower, producing just a handful of meteors per hour. On the other hand, astronomers speak of a rare fiery Draco, which has been known to send many hundreds of meteors across the sky within a single hour. Are we going to get lucky this year? Time will show. Starting from the 12th of October and for the following week, you'll have a chance to see a comet passing by our planet. Now, even though this nearly unpronounceably named big boy will be about 40 million miles away from the Earth at its closest point, you might be able to see it with the unaided eye. Now, comets have a reputation of being quite unpredictable. Most of these dusty, icy space bodies are thought to have originated on the outskirts of the solar system millions of years ago, and there they spent most of their time in the dark, inert and unnoticed, like me in middle school. Now, some of them come closer to the sun, and many experts already forecast a fantastic celestial spectacle in October. So if you miss the meteor showers we've talked about, you'll be able to catch up. Orionid meteor showers will keep going from the 26th of September till the 22nd of November 2024. Sometimes this event can produce from 40 to 70 meteors per hour, but recently the maximum number was lower, from 20 to 30 visible meteors. And the final event for this year is going to be the Geminid meteor shower. And let me tell you, this event is going to be breathtaking. Astronomers claim that this meteor shower is one of the best of the year because of bright visible meteors. Around 120 shooting stars are likely to streak across the sky per hour. Interestingly, while most meteor showers come from comets consisting of dust and ice, the Geminids originate from a rocky asteroid. Scientists still don't know how to classify this asteroid, since it has a tail and brightens as it comes closer to the Sun, just like a comet. On the other hand, recently, astronomers have discovered that the asteroid's tail is not made up of dust, but of sodium gas. Alright, let's travel farther into the future. In 2029, we'll witness the darkest lunar eclipse of the century. A lunar eclipse occurs when our natural satellite completely hides in Earth's shadow. Sometimes, when it happens, the moon can look bright red. Normally, the closer the moon is to the center of the shadow of our planet, the darker the eclipse is. And, according to experts, the eclipse on June 26, 2029 will be extremely dark. It will last for about an hour and 42 minutes and will be the most visible in South America. So, again, don't forget to book your tickets. A supermoon that's also the second full moon to occur within 1 month is known as a blue supermoon. Such supermoons don't follow a regular schedule and occur every 10 years or so. According to NASA, the next blue supermoons will happen in January and March 2037. Then, 3 years later, in 2040, we'll witness the Parade of Planets, when 5 planets of the solar system – Mercury, Venus, Mars, Jupiter, and Saturn – will line up. Of course, it won't be a perfectly straight line, but it will still be a pretty impressive view. Some planets, like Venus and Jupiter, can be clearly observed even in big cities and with the unaided eye. But during the Parade of Planets, you'll be able to see more, so perhaps it's time to stock up on telescopes. The brightest supermoon of the 21st century will occur in 2052. The thing is, the orbit of our natural satellite isn't perfectly round. The moon follows an elliptical path while traveling around Earth. That's why there are 2 points closest to Earth, called the perigee, and the farthest, known as the apogee. On the 6th of December 2052, we'll see a stunning supermoon. Our satellite will be around 221,000 miles away from our planet, which is closer than normally. In 2060, we're likely to see a comet called 15P Finlay. It will be one of the closest comets to approach our planet in the last 100 years. It'll fly by at a distance of around 3.1 million miles. And here's the thing. Every time a comet comes close to the Sun, it heats up and starts emitting gases and dust, looking like a little star. Thanks to solar winds, it also gets a beautiful long tail. And the closer to Earth a comet passes, the brighter it looks in the sky. So get ready for a breathtaking show. In 2084, something known as an Earth eclipse will occur, becoming one of the most exciting events of the 21st century. Sadly, we won't be able to see this celestial spectacle from Earth, obviously, but we might be able to admire it from Mars. During this event, the Moon and Earth will pass by the Sun, looking like dark silhouettes. Such an event is known as a planetary transit, something like a solar eclipse, but with other planets instead of the Moon. Now, in 2100, for those of us still here, the North Star will be the closest to the North Celestial Pole. Sailors have been using this famous star for centuries to figure out where North is. But the funniest thing about this is that this star isn't perfectly aligned with North. The reason is that Earth doesn't have a fixed axis. It rotates in space like a giant spinning top in a process called orbital precession. That's why the North Star doesn't remain in the same place in the sky. It moves, slowly but steadily. But on the 24th of March, 2100, the polar star will finally appear over the true north of our planet. And after that, it'll start moving away again, to return 26,000 years later. So as you can see, it's going to be a truly rare event. Plus, it'll be like a parting gift from the North Star. Since Earth's axis is constantly moving, in around 2,000 years, the North Star will be replaced by another, Gamma Cephalus. So the close approach in 2100 will be the nearest it will be to our planet for a long time. So I hope you've made notes of the most interesting astronomical events of the next 100 years. The coolest thing is that to witness most of them, you don't even need to buy a telescope. They're going to be visible to the unaided eye. Ooh, look at that! So, we just spotted an asteroid so massive it could wipe out an entire continent if it ever hit Earth. And it's moving insanely fast, almost record speed. But what makes it really scary is how it's basically playing hide-and-seek with us. It can slip right into the sun's glare and vanish completely. And yeah, it just did it again. It disappeared. So, when we finally spot it again, will we have enough time to prepare? Or could it already be too late for humanity? Yeah. Do I have your attention now? Ah, thanks. So, meet 2025 SC79. That's a mouthful, so I'll just nickname it Scooby. This newly found asteroid is a sneaky one, the kind that loves hiding in the sun's glare. Think of it as trying to spot a firefly next to a stadium light. The brightness hits your eyes and outshines anything faint nearby. So yeah, you won't see that firefly. Now asteroids hide in the same frustrating way. When they end up close to the sun from our point of view on Earth, the glare overwhelms our telescopes, and the asteroid's dim, reflected light gets lost in it. That's why some asteroids can cruise along in the sun's direction and stay basically invisible to us. And scientists say the most dangerous asteroids, the ones that could wipe out a whole city, are the hardest to detect. That's why astronomers need to somehow dodge the sun's glare. One way they do it is by observing the sky during the short window of twilight. I mean, right before sunrise or just after sunset. And that timing is a big deal, because it's the only way to catch some risky asteroid before it sneaks up on Earth. Scientists say that if one of these so-called twilight asteroids ever gets close to Earth, it could be a serious impact threat. And it was during one of these twilight observing sessions that scientists finally spotted this huge asteroid. It was September 27, 2025. Scott Shepard, an astronomer at a Washington-based institute, was scanning the sky, hunting for anything unusual in our solar system. And he had an incredible tool in his hands, the Dark Energy Camera, or DECAM, one of the most powerful sky survey cameras on Earth, built to spot faint objects across huge areas of the universe. At one point, he spotted a faint dot moving across the image, so he quickly aimed the high-tech camera at it, and things got more interesting. Its movement matched what astronomers expect from asteroids that orbit very close to the Sun. Then, follow-up observations with the Gemini and Magellan telescopes confirmed the discovery. Yes, this really was an asteroid, and there are two particularly curious things about it. First, it's fast, like really fast. In fact, it is the second fastest known asteroid orbit in the solar system. It loops around the Sun once every 128 days. For comparison, Mercury, the closest planet to the Sun, takes 88 days to go around once. Second, its orbit is super rare. This is only the second known object that stays completely inside Venus's orbit. That also puts it in one of the rarest asteroid groups out there, the Asteroids. These are asteroids whose orbits sit entirely inside Earth's orbit. Astronomers have found only a few of them so far, and Scooby is the 39th one in the list. The team of scientists also figured out that this asteroid is pretty big, measuring about 2,300 feet across. It's roughly the size of Merdeka 118, the second tallest building on Earth. If an asteroid this size ever slammed into Earth, it wouldn't just be bad, it would be catastrophic. We're talking about damage on a continental scale. It would blast a huge crater into the ground, then throw out a shockwave powerful enough to wipe out forests and wreck cities. Seismic waves would ripple through the crust, triggering widespread earthquakes around magnitude 7.4, and people could still feel them about 300 miles away from the strike. And that's not all. A brutal air pressure blast would race outward, shattering windows more than 1,000 miles away. Then comes the aftermath. Dust and debris from the impact could shoot up into the atmosphere, block some sunlight, and mess with our climate. I know, you might feel scared right now, but don't worry about it. Thankfully, Scooby isn't going to do anything like that, because it's not on a collision course with Earth. Right now, the math shows it won't be making any close passes by our planet, at least not anytime soon. Still, there's a lot more to learn about this asteroid, but any further studies will have to wait. For now, it has disappeared behind the Sun and is out of sight. Once it reappears, astronomers will take a closer look and try to learn more about what it's made of. That part really matters, because this asteroid is somehow holding up while orbiting so close to the Sun's brutal heat. You see, this asteroid gets very near to the Sun. At its closest point, this asteroid is blasted with almost 6 times Earth's sunlight. At that distance, its surface could heat up to about 440 degrees Fahrenheit. What scientists don't know yet is how a rock this big can get baked over and over again without falling apart. And there are 2 more things astronomers want to check once it comes back into view: how fast it spins and how bright it looks. Now, by bright, I mean how much sunlight it reflects, because asteroids don't make their own sunlight. They're just big rocky chunks that shine by reflecting sunlight back at us. Anyway, those clues can tell scientists what Scooby is made of. One possibility is that this asteroid is loaded with dense metal, and that could explain how it survives the Sun's brutal heat. And if that turns out to be true, this asteroid could be a relic from when the solar system was just forming. Or maybe it slowly moved closer to the Sun because the gravity of Venus and Mercury gently pulled on it again and again over millions of years. Now, even though SE79 isn't a real danger to us, and there's still a lot we don't know about it, just finding it is already a big deal. It's a reminder that big asteroids can hide from us. So even in our own cosmic backyard, there are still blind spots where large objects can stay hidden until the right moment of twilight gives them away. And as our detection tech gets better, we keep finding more and more asteroids. By now, scientists have spotted over 1 million in the solar system. They come in all sizes, from monsters like Vesta that measure about 329 miles wide, all the way down to rocks that are smaller than a house. Now, out of all the asteroids we know, about 40,000 are what we call near-Earth asteroids, or NEAs. That just means their orbits bring them close to our neighborhood. Technically, their closest point to the Sun is less than 1.3 times the Earth-Sun distance. It's close enough for planetary defense systems to keep a careful eye on them. And that's exactly why we can relax. I mean, nobody has to lose sleep imagining an asteroid slamming into our planet. Every time scientists discover a new asteroid that comes anywhere near Earth, they track it and run the numbers right away. And then they map out its path years, decades, or even centuries into the future. And they don't do it by guesswork. NASA's automated systems, like Sentry, constantly scan the asteroid catalog and calculate whether any of these objects has even a small chance of hitting Earth over the next 100 years. If something looks risky, it jumps to the top of the watch list and gets followed up fast. So yeah, there are almost 2,000 near-Earth asteroids that technically have some chance of hitting us in the next 100 years. But don't panic. Most are small and harmless, hey, like me. And their odds of impact are usually way under 1%. See why I said we shouldn't stress too much? Cool. Now, sleep tight.
Did you know that over the past year, around 150 asteroids whizzed closer to Earth than the Moon? But that's not the scary part. It's that some were only noticed after they flew by. And if even one of those had taken a slightly different path, whole cities would be gone. That's what keeps the scientists worried. The invisible stuff hiding where our telescopes can't see. Let's explore what that means. Astronomers keep a list of asteroids that wander into our neighborhood. If a rock's orbit comes close to Earth, it joins a special club we call Near-Earth Objects, or NEOs. That list can include anything from a harmless little space pebble that wouldn't break a window to a rock big enough to cause an earth-shattering kaboom. Neos are leftover materials from when the planets were forming. Some of that rubble ended up tucked safely in the asteroid belt between Mars and Jupiter, but some pieces got nudged onto paths that cut across Earth's orbit. Those are the ones we care about, because they're still wandering around today, looping around the sun, and every now and then passing uncomfortably close to us. The biggest objects are the easiest to locate. They are rare and bright enough that they stand out in sky surveys. So far, none of those big ones seem to be heading our way anytime soon. However, the real anxiety comes from the middle class of asteroids. On paper, many of them sit in the potentially hazardous object category, or PHOs, but the nickname City Destroyer explains them better. These rocks aren't huge enough to wipe out the planet, but they could flatten a city and mess with the climate for a few seasons. Some are as wide as a football stadium and hit the atmosphere faster than a speeding projectile. NASA estimates there are around 25,000 near-Earth asteroids at least 460 feet wide, but we've only discovered a fraction of them. Basically, we have solid orbits for less than half of the City Destroyer crowd. The rest only exist as numbers in simulations. We know they should be out there. We just haven't seen them yet. Why are they so hard to spot? Some asteroids are nearly coal black, blending into the cosmic night. Others hang out close to the sun from our perspective, so our telescopes get overwhelmed by brightness. It's like trying to locate a mosquito while staring directly at the sunlight. Please don't do this. From Earth, these rocks are mostly lost in the sun's glare. We only catch a glimpse just after sunset or right before sunrise. And that chance only exists if the sky is perfectly clear and the asteroid happens to be in exactly the right spot. If not, it slips back into the sun's blind spot, playing hide and seek with us. We were caught by surprise quite recently. In 2013, the Chelyabinsk meteor came from the direction of the rising sun. No one saw it in time because it was coming from the wrong direction. It exploded high above the region, shattering windows across the city and sent more than 1,000 people to the hospital. The scariest part is that the meteor was only about 60 feet wide. Now imagine a city destroyer coming from that same direction. A stadium-sized rock stepping out of the sun's glare would give us very little warning, maybe a few days or a week instead of decades. And we know that the blind zone is not empty. Observations have already revealed at least one large asteroid in that region that scientists can seriously consider a planet destroyer. It's called 2022 AP7, and it's huge. This thing is more than half a mile wide, big enough that if it ever hit Earth, it would be a catastrophic day for everyone. Astronomers found it by using the super-sensitive dark energy camera during twilight, pointing the telescope at the region of the sky most surveys normally avoided. The good news is that AP7 isn't headed straight for Earth. Its orbit crosses the orbit of our planet, but the timing doesn't line up, so we won't encounter it this pass, the next one, or even for several centuries. The bad news is what that discovery hints at. If it took this much effort to notice something like this, what else are we missing? And 2022 AP7 is just one PHO. Other asteroids closer to the sun were also spotted during those same twilight searches. New simulations say some of those hidden rocks are not random. A bunch of them seem to share an orbit with Venus. They do not orbit Venus itself. They orbit the sun in almost the same lane, sometimes a bit ahead of the planet, sometimes a bit behind, like kids jogging on the same track but spread out along the lap. Astronomers already know about roughly 20 of those Venus co-orbitals, and their paths are anything but stable. Gravity from Venus, Earth, and other planets keep tugging on them, and over thousands of years, those pulls could stretch their paths until they start crossing Earth's orbit. Most flybys are harmless, but one unlucky pass could be the one that counts. So what can we do about this? The first step is simple in theory. Find them earlier. The goal for astronomers is to launch infrared telescopes and get them into space. While we do have amazing telescopes like JWST or the Hubble Space Telescope, they're never pointed at the sun, as the brightness of our star can damage them. That's why we need a telescope in orbit around Venus, or one that travels along with it. It would be in a much better spot to keep an eye on the asteroids that hang out there. NASA is launching the NEO Surveyor project that aims to solve the problem. It should scan the inner solar system to spot dangerous asteroids in time. Also, we're learning that we can actually move asteroids. NASA's DART mission rammed a small spacecraft into a rock, which affected its orbit slightly. Not by much, just enough to prove that it can be done. It's like turning a plane just 1 degree while it's still across the ocean. By the time it reaches you, that tiny change can make it miss by thousands of miles. Teams around the world spend their days babysitting space rocks, and yes, that's a real paying job. NASA has the Planetary Defense Coordination Office. Europe has the NEO Coordination Center. Observatories feed them nightly sky data, and computers immediately check each dot's orbit. If a rock might wander too close, it joins the risk list and gets extra attention. Each new photo updates the orbit a little more. Sometimes that make the danger level rise for a moment. That is exactly what happened with 2024 YR4, when it briefly reached level 3 on the Torino scale before better measurements calmed everyone down. The scale itself runs from 0 to 10, and anything that climbs above 3 is rare enough to raise eyebrows. The whole system works that way on purpose. Notice something strange, collect more data, then decide whether to relax or stay alert. Most of the job is actually pretty dull. It's a lot of number checking, orbit fixing, and crossing out false alarms. That quiet, careful routine is what lets the world respond quickly when a rock finally appears that isn't just passing by. So how worried should we be? For those huge planet-destroying rocks, the short answer is not much. Nothing that size is on the near-term schedule. Smaller city-level threats are trickier. The odds of one hitting Earth anytime soon are still tiny, but they're not zero. Think of it as a cosmic lottery that has been running for billions of years. Every once in a very long while, the universe draws a number that makes astronomers sit up and pay attention. It's not a reason to panic. It's a reason to build better eyes in space and make sure that if a bad ticket ever comes up, we see it in time to do something about it.
Asteroids, unseen but perilous, are traveling in the same orbit as Venus, and our telescopes just can't detect them. The threat is real. If one of these objects heads toward Earth, we're all doomed. Well, maybe. In that not-so-distant, relatively of course, stretch of space where Venus orbits, there may be hundreds of asteroids we've never detected. They could be circling the Sun right at this moment, but they stay completely hidden from us. The problem is their position. Because they're closer to the Sun than Earth is, we can only look for them by pointing our telescopes almost straight toward the Sun. Any sunlight they reflect gets swallowed up by the Sun's brightness, so they basically disappear in the glare. These objects aren't part of the main asteroid belt between Mars and Jupiter. They're much closer, moving through the inner solar system. They travel in what's called a 1-to-1 resonance with Venus. It means they orbit the Sun in almost the exact same period as the planet. This makes them Venusian co-orbital asteroids, rocks that orbit the Sun in the same area as Venus instead of having their own separate path. Now, researchers use computer modeling and long-term simulations to figure out how these hidden asteroids behave and whether they could ever threaten Earth. The results aren't reassuring. The orbits of these asteroids aren't stable, their paths shift over time, and about every 12,000 years, their whole orbital setup can change. An asteroid that stays close to Venus for thousands of years can eventually drift away from it and come much closer to Earth's orbit. Now, Jupiter has its own group of co-orbital asteroids called Trojans, but those are much more stable, and the planet is so far from us that even unstable ones wouldn't be a problem. The Venus co-orbitals are different. They're close, and their orbits can change enough that some of them may eventually cross Earth's path. So even though these asteroids are invisible to us right now, the models suggest that some of them could one day get close enough to pose a real risk to our planet, even if that risk is thousands of years away. Now, even worse, scientists think that the small number of Venus co-orbital asteroids we've already discovered is only a tiny sample of what's actually out there. They suspect that most of this population is still completely unseen. Some of these hidden objects may be almost 1,000 feet wide. Such an asteroid is large enough to create a crater about 2 to 3 miles across if it ever hits Earth. Oh boy. An impact of that size would release energy equal to hundreds of megatons, causing massive destruction if it happened in a densely populated region. An asteroid would slam into the planet with enormous force, turning solid rock into vapor. Everything and everyone close enough to see the crash wouldn't live long. The ground around the impact crater would be covered with hot ash, grit, and rubble. Grass, trees, and shrubbery around the crash site would burst into flames. But that's not the worst thing. The impact would trigger a series of natural disasters, such as tsunamis and earthquakes, depending on the region. The sky would get almost completely black because of all that ash in the air. It would block the sunlight. Rainwater would get highly acidic. Fires would keep raging. They would produce enough toxins, harming the ozone layer. Earth's shield against the sun's radiation and heat would weaken. Even though humans would probably survive, the quality of life would plummet, and no one knows how long it'd last. So far, the Venus co-orbital asteroids we have found all share one thing. They follow stretched-out orbits. Their eccentricity is higher than 0.38. Eccentricity is just a measure of how round an orbit is. A value of 0 means a perfect circle. Earth's orbit is 0.017, which is almost a circle. The higher the number, the more oval the orbit becomes. And since these known asteroids follow a long stretched path, they can drift far from Venus and swing closer to Earth. When that happens, we can sometimes spot them during twilight, when the sun is below the horizon but still bright enough to light up small nearby objects. Scientists wanted to understand the asteroids we couldn't see yet, especially the ones with more circular orbits. They ran simulations to study how those lower eccentricity asteroids might move, whether any of them could threaten Earth in the near future, and whether the new Vera Rubin Observatory, with the biggest astronomy camera ever built, would be able to spot them. The results showed something worrying. Even some low eccentricity orbits could bring long-term risk to Earth. Even worse, the Rubin Observatory will only be able to see these objects during short windows at certain times of the year. That means many of them could still slip by unnoticed. Now, this creates a real problem for planetary defense. It's hard to prepare for the danger if you can't see it coming. One way to fix this blind spot would be to place a space observatory near Venus, or even in the same orbit as Venus, so it can watch that region directly. NASA's upcoming NEO Surveyor mission might also help by studying the inner solar system, where these objects hide. In the end, scientists think ground-based surveys like the Rubin Observatory will catch some of these asteroids, but not all. To map the full population of Venus co-orbitals, we'll need a dedicated space mission close to Venus. Right now, astronomers have identified only 20 Venus co-orbital asteroids. All but one have an eccentricity higher than 0.38. These stretched-out orbits carry them farther from the Sun, where telescopes on Earth have a fighting chance to spot them. But there should be many more asteroids with more circular paths that stay closer to the Sun's glare. So, what if we spotted a visitor from Venus when it was already approaching Earth? What would we do? Well, we could launch a bunch of nuclear explosives at the asteroid. If we could just blow it to pieces while it was still far away, the debris would scatter safely into space instead of causing problems near Earth. On the other hand, what if the explosion accidentally changed the asteroid's path and sent some fragments toward Earth? It's a real possibility. Or we could gently nudge it off its course toward Earth. But it would only work if we knew exactly the weight of the asteroid. Without knowing its mass, space agencies wouldn't be able to design a precise mission to knock it off course. In theory, they could send out a reconnaissance spacecraft first, something to get close to the asteroid, measure it, and figure out the best way to push it away. But what if we didn't have enough time for that? By the time we collected all the needed data and built the right hardware, it'd be too late to intercept the asteroid. By the way, NASA actually has some experience with asteroid defense. Back in 2022, they pulled off something groundbreaking with their Double Asteroid Redirection Test, or DART. That mission was all about proving that humans could physically change an asteroid's path without using explosives. NASA launched a small spacecraft in November 2021, and after almost a year of travel, it crashed head-on into a tiny asteroid named Dimorphos at about 14,000 miles per hour. The idea was simple. If you hit an asteroid hard enough, you can slightly change its orbit, just enough to make it miss Earth someday. And it actually worked. The test showed that even a relatively small spacecraft could make a major difference. Now, the European Space Agency wants to double-check exactly how much of an effect that crash had. In October 2024, they launched a follow-up spacecraft called Hera from Florida's Cape Canaveral Space Force Station. Hera's on a 2-year journey to reach Dimorphos and its bigger partner asteroid, Didymos. By October 2026, Hera will enter orbit around the asteroid pair and start collecting data, basically checking NASA's math. ESA scientists hope that once they analyze the impact site, they'll find out how effective DART was at changing the asteroid's trajectory. In any case, planetary defense has to think about more ways to protect the planet from wayward asteroids. It also has to take seriously the things we still can't see.
Remember that asteroid that wiped dinosaurs off the face of the Earth? Brace yourself, we might witness a similar scenario in our lifetimes. And this time, the consequences might even be more catastrophic. There's just one tiny difference. This new asteroid is likely to smack into the Moon. No, this is not a sci-fi scenario anymore. There's this asteroid called 2024 YR4 that scientists say has about a 4% chance of hitting the Moon in 2032. So what do? Try to gently shove it off course or blow it up? A bunch of researchers, including people from NASA, dug into this and suggested several options. Their worry is real. If that rock hits the Moon, it could kick up a massive cloud of debris, and this cloud could spike to as much as 1,000 times normal levels for a few days. That's not just messy, it could endanger astronauts and satellites in low Earth orbit. One obvious idea is to nudge the asteroid so it misses the Moon. Another is a full-on breakup. Basically, a deliberate explosion. Experts use a clever term to describe it, a robust disruption. But nuking an asteroid is totally untested. Nobody has ever done it before, and it carries huge risks. You could create a bunch of smaller but more dangerous fragments, or do something unexpected that can make things worse. In any case, the idea is out there for scientists to chew on. Now here's the backstory. 2024 YR4 was first spotted on December 27, 2024, and reported to the Minor Planet Center. That's the official hub that tracks all new asteroids and comets. Pretty soon, it showed up on NASA's Century Impact Risk Table, which is like the agency's watch list for any asteroid that could potentially hit Earth. For a little while, things looked sketchy. Out of 37,000 plus known large asteroids, YR4 was the only one with a real chance of smacking into Earth anytime soon. Its odds even climbed to a record 3.1%.
That might not sound like much to such amateurs as me and you, but in space terms, that's huge. Scientists were really paying attention. Luckily, after a few more months of better tracking and sharper observations, they nailed down the asteroid's orbit more precisely. Turns out its path isn't taking it anywhere near us after all. Its chance of hitting Earth has dropped so low it's basically zero now. So, we can breathe out and relax. Earth is safe. But the Moon? Maybe not. And that's why researchers are now debating whether to blow the thing up before it ever gets close. The thing is, asteroid 2024 YR4 is pretty big. Based on what the James Webb Space Telescope saw, it's about 220 feet long, roughly the size of a 20-story building. Not exactly a pebble, I'd say. At first, NASA thought there was only around a 1.7% chance that YR4 would crash into the Moon. But then, the Webb telescope checked again in March, and that number jumped to 3.8% right away. By May, it climbed once again. It was already sitting at about 4.3%. In other words, the more they looked, the more likely it seemed that this space rock might actually hit our natural satellite. On the bright side, these new observations helped NASA figure out where exactly the asteroid would be on December 22, 2032, with about 20% better accuracy. Now, if the asteroid really did smash into the Moon, NASA says it wouldn't mess with its orbit or make it wobble or anything dramatic like that. And this is a very big but a hit from something that large would kick up a ton of debris. And that flying space junk could become a real problem for satellites orbiting Earth, or even for astronauts on the International Space Station. That sounds alarming enough. That's why the story might take a turn straight out of a sci-fi movie. Scientists are seriously considering blowing the asteroid up. But unlike in a movie, this isn't about saving Earth this time. The most extreme idea is to launch a bunch of nuclear explosives at the asteroid before it reaches the Moon. The thinking is, if they can blow it to pieces while it's still far away, the debris will scatter safely into space instead of causing problems near Earth. But of course, there's the catch. While scientists know roughly how big YR4 is, they don't know exactly how much it weighs. And that's a huge problem. Without knowing its mass, space agencies can't design a precise mission to knock it off course. In theory, they could send out a reconnaissance spacecraft first, something to get close to the asteroid, measure it up, and figure out the best way to push it away. But researchers say there just isn't enough time. By the time we'd collect all the needed data and build the right hardware, it'd be too late to intercept the asteroid before the 2032 impact window. So instead of a gentle space nudge, some experts suggest going full Armageddon-style, that very robust disruption. Translated into human, it's blasting the asteroid apart with nuclear explosions. Sure enough, this idea comes with a massive risk. What if the explosion accidentally changes the asteroid's path and sends some fragments toward Earth? The researchers admit it's a possibility, but still think nuking it could be the most practical solution, given the circumstances. If the mission ever happens, it would need to launch sometime between 2029 and late 2031. This would give it just enough time to reach and intercept the asteroid before it gets too close to the Moon. Now, nuking space rocks might sound over the top, but NASA actually has some experience with asteroid defense. Back in 2022, they pulled off something groundbreaking with their Double Asteroid Redirection Test, or DART. That mission was all about proving that humans could physically change an asteroid's path without using explosives. NASA launched a small spacecraft in November 2021, and after almost a year of travel, it crashed head-on into a tiny asteroid named Dimorphos at about 14,000 miles per hour. The idea was simple. If you hit an asteroid hard enough, you can slightly change its orbit, just enough to make it miss Earth someday. And it actually worked. The test showed that even a relatively small spacecraft could make a serious difference. Now, the European Space Agency wants to double-check exactly how much of an effect that crash had. In October 2024, they launched a follow-up spacecraft called Hera from Florida's Cape Canaveral Space Force Station. Hera's on a 2-year journey to reach Dimorphos and its bigger partner asteroid, Didymos. By October 2026, Hera will enter orbit around the asteroid pair and start collecting data, basically checking NASA's math. ESA scientists hope that once they analyze the impact site, they'll find out how effective DART was at changing the asteroid's trajectory. If it turns out that kinetic impact, aka smashing a spacecraft into an asteroid, works well enough, future missions might use that technique again. Maybe even for YR4, if it ever becomes a real threat. But if it doesn't, that's when the nuclear backup plan might come off the shelf. Either way, scientists are making sure that if a space rock ever threatens Earth or the Moon, humanity will have more than just a Hollywood script to rely on. By the way, people at NASA run what-if asteroid exercises every 2 years to get scientists, state agencies, and international experts on the same page. During such asteroid drills, experts pretend that a giant space rock is heading our way. Then they work through all the tricky questions they can come up with, like how big is it, where might it hit, what should we do? It's like a massive brainstorming session to make sure that if this ever happens, we won't be starting from scratch. To make these scenarios feel as real as possible, NASA's Center for Near-Earth Object Studies gets involved. These are the folks who track real asteroids and calculate their orbits. So they simulate months of asteroid observations, complete with uncertainties about its size, trajectory, and potential impact zones. No one knows exactly how big the asteroid is or where it can hit. It's the kind of uncertainty that makes decision-making way harder, just like it would be in real life.